Hi, this is the South County Math Tutor. I'm here and ready to begin our lesson on exponents. Okay, so I am ready and I hope you are ready. I will make a suggestion. I suggest that you write your own notes so that you can have that when you are solving these problems. Okay, so what are exponents? Why do we have them? Why should we even care? Okay, so, well, let's say you want to do 2 times itself. 2 times itself. 2 times itself 3 times. 2 times 2 times 2. Well, that's easy to write. You just say 2 times 2 times 2. You write it down, you say 8. What if you want to write 2 times itself 100 times? Right? 2 times itself 100 times. Well, that becomes really difficult. And the way we do that is we put this number like that raised on top of it. Okay, that's called an exponent. Okay, so it turns out, definition, a to the n power. This is called a base. This is called the base. Okay, and this is called the exponent. And it's telling you to take something, a, and multiply it by itself n times. Take a, multiply it by itself n times. So for example, if you had 3 to the 5 power, it's telling you to take 3 and multiply it by itself 5 times. And I will okay, so let's just go ahead and do it just for the sake of it. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. 81 times 3 is 243. The good thing is you have a calculator. You don't need to do this in your head. You can go ahead and use your calculator if they happen to have a problem like that on the test. Okay, we have exponential rules. Okay, we want to figure out easy way to do operations with exponents. Okay, so here are the rules, and you will get this worksheet on the website. I will upload this worksheet so you don't have to worry about copying it really fast unless you want to. Okay, rule number 1 is called the product rule, and it's telling you that anything with the same base, so they both have x's as a base, raised to an exponent, and if they're being multiplied, you add the exponent. Okay, if it's a number and it's being raised to a power, you multiply the exponent. Okay, what if they have different bases? Okay, well, x to the m times y to the m, there's nothing you can do with that. You cannot combine it in any way, so that's just your answer. Okay, what if they have 2 different bases and they're being raised to a power? Then you're going to have to multiply each one. It's almost like you're distributing. If you know what distributing means, you take x to the m and then times the power of z. Y to the n times the power of z. Okay? What if you have division? So let's go ahead and write the division like this. X to the m divided by y to the n. Okay? All raised to the z power will give you x to the mz over y to the nz. Okay? Negative exponents. Negative exponents are not, what negative exponents mean is change the position. So x to the negative n will be, if it's on the top, you move it to the bottom. If it's on the bottom, you move it to the top. So that's the general rule. And we're going to do some examples of these so that we make sure we understand it. Okay, quotient rule. X to the m divided by x to the n. They have the same bases, so what you do is you write the base and you subtract the exponent. Okay? And that's about it. Let's go ahead and try to do first let's do some easy examples. So go ahead and practice this concept. So I'm going to call this easy example. This is the kind of example that if you have on the test, you just jump around in your heart and say, yay, this is an easy example and I can do it. Perfect. Okay, so easy example number one. A cubed times a squared. Okay, notice, same basis. Write the base, add the exponents. A to the 3 plus 2, a to the 5th. Okay, easy example number two. A cubed divided by a squared. Again, same basis. Write the base, subtract the exponent. Okay, and I'm going to show you some tricks with subtracting exponents. A to the 1. A to the 1 is just like saying A. Okay, easy example number 3. What if you had a to the negative 2? A to the negative 2. That just tells you change the position. This is actually 1 over a squared. So you take that, you move it to the bottom, and the exponent becomes a positive. Okay, what if you had 1 over x to the negative 2? Again, change position. X, bring it to the top, x squared over 1, which is the same thing as x squared. Okay, what if you had x, y to some variable n? That would be x. Notice how they're different bases. All you do is what I call distributed. So for each one, you just tag the n exponent. So x to the n times y to the n. Okay? Number 6. What if you had a cubed times b cubed? What do? You ask yourself, do they have the same basis? The answer is absolutely not. This is an example of me trying to make sure that you were paying attention. They don't have the same basis. There's absolutely nothing you can do. A cubed, b cubed. It's just a cubed, b cubed. Okay. Now, what if we have numbers and letters together? How does that work? So let's look at more example. Let's call this medium. Okay, so medium examples, not too easy, but it's not too difficult. Okay, medium example number 1. 2x squared times 5x cubed. Okay, so here's the general rule. You want to, if you have numbers, you do your regular operations with numbers. So what you have here is 2 times 5. You want to multiply the numbers. Multiply. Actually, let's go ahead and define something before we even go here. Okay. So let's use a realistic example. Let's say we have 2x to the third. Okay? This is called a coefficient. Number in front of a variable. Coefficient. Okay? And then this is a variable. A variable is a letter that represents something. So x is a variable, and this is the exponent. Okay, so coefficient is number in front of a variable. And of course, this is the base because the x is being raised to the power of 3. Okay, so what you want to do when you have mixed problems like this is you multiply the coefficient. This is not new. This is what you've always done. When you see numbers, I call it the big number. Coefficient is I call big number. Exponent I call small number. Okay? Multiply the big number, 2 times 5, and add the exponents. X to the 2 plus 3, which is 5 power. Okay? Number 2. Let's say you are dividing 100 a cubed divided by 10 a. Okay, so what you do is this time you're dividing your regular operation for your number, your big number, your coefficient is division. 100 divided by 10 is 10. a cubed. What is the power to this just a? Whenever you have a variable with no exponent, the exponent is assumed to be 1. Okay, so a cubed divided by a to the 1 power, you subtract the exponent, so 3 minus 1 is 2. So this is 10a squared. Okay, so now let's try to do several operations together. So let's say you have 2x squared y times 5y cubed. Okay, one step at a time. You have coefficients, big numbers. 2 times 5 is 10. It's being multiplied. So just regular operation, 2 times 5 is 10. Then you go to the next thing. You have x's. You don't have another x. So you just tag it on to your answer. X squared. And then y to the 1 times y cubed. Add the exponent. So this is y to the 4th power. Okay. So let's look at another general rule that is not addressed here. Okay. So as you can see, I did not put this together. So didn't have everything. So let me go ahead and give you a general rule. Anything raised to the 0 power equal 1. That's something you need to know. Anything raised to the 0 power equal 1. 5,670,500. How much I wish was in my bank account raised to the 0 power, but I don't want you to raise it to the 0 power, is 1. Doesn't matter what it is, complicated variable times 3 minus 5, 2, 3, 1. If it's raised to the 0 power, then it equals 1. Okay, so let's do some difficult examples. I'll call that interesting example. Interesting examples. Okay, interesting examples. Let's go to this lovely worksheet that I created. That's going to be on the website, and it will have all my worksheets, have all the answers at the end so that you can check your answers. Okay, so that's what I do to make sure. I want you to know when you're getting things right. So I will give you the answers. I don't want you to cheat, but I do want you to use it as a tool. Okay, so these are interesting examples because they have several operations within them. All right, let's go back to so many things on my computer. Okay, so interesting examples. Let's paste it. And I pasted it all the way up there. I don't want to do that. Undo. Okay. I want to go ahead and move create a table. That worked? Okay, so hopefully I can write on this. Okay. So interesting example number 1. So a lot of things going on with this problem. My first thing is I'm going to go ahead and something raised to the 0 power, I'm going to go ahead and do that. I know that y raised to the 0 power is 1. Okay, 1 to the negative 3. And then 2y squared times 2yx negative 2. Okay, so what you want to do is go literally you want to go one step at a time. Okay, so one step at a time.